Okay, so we started here the examples on the beta and gamma. The first question is on the screen where we have integral 0 to infinity e raised to minus x square dx. Uh, uh, all these examples we can solve by a proper substitution. If we select a correct substitution, it can be reduced to the standard form of a beta or standard form of a gamma. In this case, this question can be solved by the first definition or the second form of the gamma. But if we want to convert this in the first form of the gamma, the standard substitution should be let that x square is equal to t. Let x square is a t. If x square is a t, so we can observe the value of x is a t raised to half. Why I am calculating always these values of x? Because we have to replace each and everything from the integral in terms of a t now. So x square we can replace is a t, but we have to replace the value of dx also. So let me calculate that dx here. So this dx become 1 by 2 t raised to minus half dt. Can anyone tell about about the limit? Can limit remains the same or different?
So it remains the
Same.
It will
same.
remain same, correct. If x is a 0, you'll observe x is 0, t is a 0, and when x is infinity, t is infinity. So from the substitution only. So the integral I, that integral I, given integral I will become in a variable t now. So it's a 0 to infinity e raised to minus t, and the value of a dx is 1 by 2 t raised to minus half dt. Obviously the simple thing that we can do it, constant 1 by 2 can be taken outside, and we're left with the integral 0 to infinity e raised to minus t t raised to minus half dt. Can anyone tell the value of this integral?
So gamma 1 by 2.
Gamma 1 by 2. Is the Tejas given the answer? Is it? Okay. Gamma 1 by 2 is the correct answer. Why this is gamma 1 by 2? Because we can compare. We have this definition. You can see that definition. Gamma n is integral 0 to infinity e raised to minus x raised to n minus 1 dx. So if the power of x is n minus 1, outside is a gamma n. So this minus half is like n minus 1. So if you are to write in gamma, so just you have to add 1 there in the power of t here. So minus half plus 1 is a plus half. So the value of that integral, I becomes, this is 1 by 2 gamma half. That's 1 by 2 gamma half. And this is just we added 1 in the power of t and we get that gamma half. What is the value? This is already we proved.
Root pi.
Root pi, correct, Ankit? Yes, root pi by 2. That's the final answer, and that is the end of the question. So value of this given integral is root pi by 2. Okay, so complete it. If you have the doubt, you can ask. Once you complete, tell me. We'll move to the next question then, okay? So this question is already asked in 2012, 13 and 16. So generally these questions of 2 marks only. Okay. If the question come for 5 marks, the 2 bits will be there. 1 bit from beta and 1 from the gamma there. That way. Okay. So Sanket, yes, you completed. Good. So can we move to the next question? Yes. Okay. Okay. Next question then. See the question and think about substitution. The most important thing in all these examples is substitution. Can you tell what should be a substitution which gives us a beta or a gamma?
Y is equal to t square.
Okay, Ankit, that is okay. Y equal to t square, or just that root y is a t.
Root
Both
y,
are same. Correct, Sanket. Okay. So Where is that? Let root y is a t. If root y is t, we want to replace the value of dy also. So that gives y is a t square and the value of a dy as a 2t dt. If all these things are here, so now the integral will become, this integral I will become, limits again remain same. You can observe when we replace that y by 0 t is a 0, y by infinity t is infinity. The integral 0 to infinity, the value of a root y is a t, yes, this is e raised to minus t, and the value of a dy is a 2t dt, correct. So keep one thing here that is important, that when you convert the integral, when you use substitution, write each and every terms in the new variable. Few students have the habit that they write half of the terms in terms of x and half of the terms in terms of t. So that is not a correct way of writing, because when you transform the double integral, this integral, that should be entirely in the new variable then. Now this can be rearranged. The 2 is a constant outside. It's a 0 to infinity e raised to minus t t square dt. And what is the value of this integral now?
Gamma 3.
Gamma 3. Correct. So just you have to add 1 to the power of t. So this is a 2 plus 1, that is a gamma 3. So 2 gamma 3. And what is the value of gamma 3?
2.
2 factorial.
2 factorial, correct. And that's the required answer. Here we use this result. Gamma n plus 1 is n factorial for integer, n as an integer. That's what. So complete this, and once you finish, tell me. Done? Are you completed? Okay. So can I move to the next question here?
Yes, sir.
Okay, so the next one.
Yes, sir.
Yeah, thank you. So all you can see now, this is a little different question. The substitution is not so easy. Can anyone guess here?
A raised to x is equal to e raised to t.
Okay, Ankit, very good. You probably gone ahead of this. Okay, you may done that. Very good observation. So a raised to x is a e raised to t. That is a substitution. Why that is? You'll observe this x raised to a. First of all, this x raised to a is an algebraic function, while a raised to x is an exponential function. So our aim is to get that e raised to minus x term, e raised to minus x term. So this a raised to x is exponential with the base a, that can be converted in the base e form. So here the substitution is let a raised to x is e raised to t. Okay, so that this a raised to x, when we take in the numerator, it become e raised to minus t there. Okay, that way. So we want the value of x also, because x is there, and value of dx. So for that, let me take log on both sides. So x log a is equal to t log e, but the value of log e is 1. So the value of x become t upon log a. If the value of x is t upon log a, the value of dx will be just dt upon log a. And let me check a limit. When x is 0 in this expression, if you observe, x is 0, t is 0, x is infinity, t is infinity. So limits remains unchanged. There is no need to check the limits because they remains unchanged. Come to the integral now, given integral I. So that become limit remains unchanged, 0 to infinity. The value of x is a t upon log a. that just we checked here. This is x raised to a. So this is a t upon log a raised to a. The a raised to x. A raised to x is e raised to t, but we are taking in the numerator. So we can write it like e raised to minus t. And the value of a dx is a dt upon log a. Next step, can anyone tell me? Yes, Ankit.
We will common 1 by
Log A would
Correct.
be
Log A
common as
will-
outside.
Constant is a
So
log a, and the power of log a is log a raised to a plus 1. That is a constant term which can be written outside the integral, and we're left with t raised to a e raised to minus t dt. And what is the value of the integral now, where t a is a constant, a is some constant, just the required
gamma
answer.
a
Gamma
plus
A
1.
plus 1.
Gamma a plus 1, that's a required answer. Gamma a plus 1 upon log a raised to a plus 1. So what are the most important thing in all these examples? The most important thing is this starting line, that you should click that correct substitution. So this one is important. This is important. You should get the substitution. If you start with the proper substitution, the example is really simple. Okay, and hardly there are 3 to 4 types. So 3 types only. So just we completed 2 types there. In previous case, we observed whenever exponential term is appeared, we just making its power linear negative. Like e raised to x square is there, then we replace x square by minus t. If e raised to root x is there, we replace root x by minus t. Okay, that way. So that is a case 1. Case 2, a raised to x may be appeared, and that time we replace that a raised to x by required e raised to minus t if a raised to x in the numerator. But right now a raised to x in the denominator, so replace it by e raised to t there. And there is one more case, last case, we'll see that after this question. So first you complete this. Okay, Sanket, you completed. What about others? Can we move to the next then? Next question. If everyone
Yes, sir.
Okay, good.
Yes, sir.
Okay. So fourth question on beta and gamma here. Next. Yes, now the substitution. Yes, what should be a substitution here? See the
Log x is equal to
We'll take log x is equals to minus t.
yes, correct, Swastik. Log x is equal to minus t. The important thing, first of all, you will observe here, in this case, the limits are not in the required form. Actually, for gamma, we require 0 to infinity. They are 0 to 1. But even though they are 0 to 1, we can transform this double integral. We can transfer this double integral to the gamma there because of log x function. Log x will convert our limits in the required form also. So whenever log x appear, this is the last case in the gamma. So whenever log x appear, that example also, okay, majority of the times can be solved by a gamma. So in this case, the required substitution is a log x should be replaced by minus t. Why minus t? Because we require e raised to minus again. Okay, so this gives us the value of x as e raised to minus t, and that we require actually. We require e raised to minus t term there. So this will be appeared because of minus t only. And one more thing that would replace, which is the dx, and the dx is a minus e raised to minus t dt. That's a derivative only, the derivative of x. Now, important thing in this question only, we require limits because limits not remain same. So if we use this original equation to check the limit, when x is a 0, you will observe log 0 is not defined. Log 0 is not defined, so t becomes infinity. But when x is a 1, log 1 is a 0, so t becomes a 0. So the limits, if we observe the new integral now, that integral I, this integral I will become from infinity to 0, the value of x just we seen here, x is a e raised to minus t, and the value of log x is a minus t. bracket raised to 4, and the value of a dx is minus e raised to minus t dt. So just it is replaced, all values are replaced. Now one thing that we can do it with this minus sign we can use it to change the order of limit. So one minus sign I will use to change the order of limit, so it becomes 0 to infinity. This become e raised to minus 4t. Okay, this is e raised to minus 4t and e raised to minus t. What should be the power of e then?
minus
Just
5.
minus 5.
Minus 5t, correct. E raised to minus 5 and this is a t raised to 4. T raised to 4 dt. That's only we left. Next step now. Anyone? What should be the value?
T is equal to Z.
Phi u t is equal to z. Good. Yes, very good, Ankit. So this now this is not in a standard form yet. It is not in a standard form of a gamma, because in gamma we require only e raised to minus x term. Okay, e raised to minus. This is a phi u t. The linear term should be appear there with a negative coefficient only, -1 coefficient. Here is a -5 coefficient, so that is not in standard. So phi u t is a z, or phi u t is equal to y. That is one of the way. There is one more way, but for that you should remember that property. What is the property? Yes, anyone knows that property?
Divide by 5 raised to n.
Gamma n by k to the power n. Where k n everything is 5.
Yes, very good. So here in this case, that property, if you recall, we seen this property e raised to minus kx x raised to n minus 1 dx. We proved this property in the gamma, and you can use it to solve the example also if you want. But if you don't want to use the property, yes, you replace phi u t by y or phi u t by z, anything new variable. So it is a gamma n upon k raised to n. So this is the property we proved already in the gamma properties. And now with the help of this property, we can get the answer in one step only. The integral I will become, in this case, this is a gamma n, means just add 1 there, gamma phi u. The value of k is also phi u, so phi u raised to phi u. And gamma phi u is a 4 factorial. And this is phi raised to, and we have a required answer, which is a 24 upon 3125. Okay, so that is the end of the question. If anyone have a doubt, yes, you can ask. So already I told these questions are coming for 2 marks mainly. Okay, there's no doubt. Good. But all these questions comes generally for 2 marks, 2 mark question. So can I move to the next slide? Yes, Swastik, why you raised the hand?
Sir, here we integrated x cross log x. Sir, how can we integrate log 1 by x?
Log 1 by x means you are asking about any example there, numerical. Means instead of log x,
Yes.
there is log of 1. So that time also you can replace that log of 1 by x by t. So you'll automatically get that if log of 1 by
Okay.
x is t, then x become e raised to minus t there. Okay.
Okay, sir. Okay.
Yes. Correct. I think that example is in tutorial there. Yeah.
Yes, sir, that is.
Correct. Anything else? No. Okay. So let I summarize all types of examples of gamma. So for the gamma, you will get these types of example. So most important thing, you should start with the proper substitution, then obviously you will reach to the correct answers. And you should have something in your mind that by putting this substitution, you are going to transform, or you are going to convert the integral in that form of a, okay, either in the first definition of gamma or second definition of gamma or the beta there. So the first example that you can observe there, where obviously the substitution is this power ax raised to n, this should be t, so this become a gamma then, first definition of gamma. This log x, just we seen one similar example here. Here is log 1 by x. If log 1 by x is t, so you'll observe log 1 by x means log of x raised to minus 1, that is t. So this is minus log x is t. So that is log x is minus t, or x is e raised to minus t. So this way. Okay, so this log of 1 by x is t can be replaced, and you can solve it by a gamma again. A raised to x equal to e raised to. So these are some standard integrals and the standard substitution which converts the integrals in the standard form of a gamma, and we can evaluate it easily then. Okay, any doubt in the gamma then? No doubt.